of form for a quadratic. So we already talked about standard form. Now we're going to talk about another form called vertex form. So go to the next page in your packet and do me a favor and clamshell your Chromebooks right now. You don't have to put them up, just clamshell them. So, vertex form of a quadratic. All right, it's just another form. Okay, so it doesn't necessarily look like standard form. So we know standard form to typically look like y equals ax squared plus bx plus c. That's standard form. Vertex form is going to look a little different. So vertex form is y equals a times x minus h squared plus k. All right. Now, that probably means nothing to you yet, and that's okay because we're going to discuss it. So, they're basically still quadratic functions. They're just written in two different ways. So, any quadratic can be written in its standard form, it can be written in its vertex form, and then we can also write it in its factored or intercept form sometimes. All right. So before we even do anything with vertex form, let's first discuss the parent function of the quadratic. So we've already talked about this before. The parent function of the quadratic is x squared. So remember, that just means that any quadratic is just a transformation of x squared. So any quadratic graph is just a transformation of x squared. All right, it was stretched, it was compressed, it was shifted, it was reflected, but it all stems from x squared. So first off, let's actually graph it. So I'm going to go with my general points. All right, those are typically the x values you would get in Desmos. Now, if I wanted to find those by hand, okay, x squared. What's the only thing I would have to do to those x values to get the y's? Right, John? Just square them. So what's negative 2 squared? 4. Negative 1 squared? 0 squared? 1 squared? And 2 squared. So before I even graph this, where's my vertex? Someone has not talked yet today. Where's my vertex? It's at 0, 0. How do you know it's at 0, 0? How do you know 0, 0 is my vertex? Because it's where first off, it doesn't repeat, but it's also where the other y values start to repeat after it. All right. So it goes 4, 1, 0, and then after 0 goes 1, 4. So the y values start repeating again. So I'm going to take a minute and graph this. So I have 0, 0, negative 1, 1. So that means its axis symmetry reflection partner is 1, 1. Negative 2, 4. Axis symmetry partner is 2, 4. So it looks like this. Now, just for funsies, where's the axis of symmetry? So where is the axis of symmetry? What is it? Come on, guys. We did a bunch of this yesterday. Where's the axis of symmetry? X equals 0. All right. So at x equals 0, that's my axis of symmetry. So that's just the y-axis. All right. Now, there is technically a pattern for the parabola at the vertex. All right. So what it is that it's based off of the a value and the x squared. All right. So for example, if you have x, your y equals that x squared. All right. So if we were looking at the graph, it's almost like doing rise of a run for a linear. All right. Except now you do the run first and then you rise. So if your run is equal to x, so that's how many you go out to the left from the vertex, is x units from vertex. Your rise is equal to x squared units from vertex. So what does that mean? All right, example. All right, if I want to go one out from the vertex, so my run is 1 unit from vertex. That means my rise would be 1 squared up because it's not negative. So 1 out, 1 up. So if I go 3 out, what would be my rise? So my run is 3. So my rise would be 3 squared. So that would be how many units up? Be what? Guys, what's 3 squared? 9. So it'd be 9 units up. All right. Now I didn't draw this graph perfectly, but that's where it would be. Crap. All right. So now let's look at this first example. So this is an example of a quadratic in vertex form. So here's what I want you to do. I want you to graph that function in Desmos. And I want you to find these key features. So the vertex, the axis of symmetry, its max or min, the minimum, maximum value, and the y-intercept. Yeah.
It's not good. It's just not working. Oh, thank you. Thank you.
So you're graphing that function in Desmos. You don't need to graph it on your paper just yet. I just want you to find the key features from Desmos. By the way, if you need help in the graphing department, you can look up here. So you do the parenthesis, x plus 4, close that parenthesis, then square it, and then plus 5. Heads up, guys. Come on. I know it's Friday, but push through. So find all those key features. Jeez. There we go. So once you find all the key features, just stop. Guys, base that on the minimum value, remember, which is the y value of the vertex. Thumbs up if you're ready. One minute. Nope, we'll talk about that together. I just want. Alrighty, my darlings. Let's go over this. So, let us go with. Where's that big one? Not here. Not here. Jeez, I'm 3 for 3. Kaylee, what's the vertex of this function? Say one more time. -4, -5. Good. So -4, -5 is the vertex. What is the axis of symmetry? Caden with a K. Not x equals 0. What's the x value of that vertex? So what's the x value of the vertex right here? X equals -4. There you go. Now, is that vertex going to be a max or a min? Oh my gosh, I keep drawing people who are not here. Jared. It's a min. Good. Now, what is the minimum value? So that's the y value of the vertex. Abby. -5. And then finally, what's the y-intercept, Micah? Good. All right. Now, let's see if we can graph this using the trick. So the very first thing that you're going to do when you use the trick is you are going to put down the vertex. So -4, -5. So remember, however far you go out from the vertex, you go that far out squared up. And since there's no a value, we don't have to multiply it by that a value either. We just got to do x squared. All right. So if I go 1 out, how far would I go up? So what's 1 squared? 1. So 1 out, 1 up. And since we have an axis of symmetry, I do the same thing on the other side. If I go 2 out, how far up do I go? 4. 1, 2, 3, 4. Do the same thing on the other side. That's the beautiful thing about the axis of symmetry. If you get one side, you automatically have the other. If I go 3 out, how many am I going up? 9. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9. And then I got the same distance on the other side. And that should be enough to give us an idea of what this looks like. All right. So my graph will look something like this. Now, you could have also just gotten points generated from Desmos and done it that way as well. But the thing with that is that you have to include the vertex. So my rule of thumb is if you make a table, the vertex should always be your middle point. So -4, -5. And you just need to do the same distance on the other side. All right. So I usually do 2 lower, 2 higher. In this case, I did 3 lower, 3 higher. All right, so this is XY, vertex is right here. I then did -5, -6, -7, -3, -2, -1. Now, what value did I get for -5 and -3? What's the Y value that I got? So look at the points. We graphed these same points. What's the Y value that I got for -3? -4. So -5 was the same thing because that's its reflection buddy. What did I get for -2? What Y value did I get? -1. So there's its reflection buddy with -6. Then for -1, what did I get for Y? 4. So there's its reflection buddy with -7. Now, we know that every transformation comes from the parent function. All right. So here's my question. What transformation did you think happened between these two functions? Did it look like it got wider, thinner? Did it shift? What do you think? Like just in general, what do you think it did? Do you think it shifted? Do you think it got wider or thinner? Do you think it reflected? What do you think? Owen?
I honestly think it may have shifted.
It just shifted. All right. So it just shifted in this case. The question is how much? And the way we can tell is by looking at the vertex. So if I look at the two vertices, so my original one is 0, 0. All right. So I'm going to plot that here. This is the parent function vertex. What did I do to get from the parent vertex to my current vertex? So in other words, how many units did I go in a certain direction horizontally? How many units did I go vertically to get there? So what's my horizontal shift? 4 to the left. Good. 1, 2, 3, 4. So we went left 4. And then what do we do vertically? Down 5. 1, 2, 3, 4, 5. Now, if we review, okay, now, so that means if I had the point XY, so think of XY as 0, 0, okay? So another way we can think about this is XY was 0, 0. That's our point. What did I add to the X? What did I add or subtract to the X value to get my new X value? So to get -4, I subtracted 4. All right. Now, what did I add or subtract to my Y value, which in this case was 0, which is the original, to get to my new Y value of -5? What, huh? So how did I get from 0 to -5? I subtracted 5. So when I did that, that gave me my new vertex of -4, -5. Now, look at what we mapped out here, and then look at the original function. Is there anything that kind of is pretty consistent? Do you guys see anything that is kind of ringing a bell that looks familiar from the old function? Or from the function that we originally graphed? So that one right there. So the question is, why do you think they call it vertex form? So that function's in vertex form. Why do you think they call it vertex form? Are there some numbers in there that look familiar to you? It's got the vertex in it. If you look right here, there's the -5. But they got a +4 here. But that's because what we're about to discover in the original formula, which I wrote up here, the original formula has a minus. All right, so that means, which we know that the vertex is -4. Well, what's a negative times a negative? A positive. So that could be rewritten as x minus -4. And it became a positive. So why is it called vertex form? It has the vertex in it. It tells you the vertex. And that's exactly what this next part will mean. So the formula for vertex form is y equals a times x minus h squared plus k. Now, just like with standard form, your a value still determines the direction of opening as well as the pattern multiplier. So in other words, for example, if a was equal to 2, that means if you went x units to the left, you would do 2x squared up. All right. That also means that if it's negative a, you have a max. If it's positive a, you have a min. Still consistent with standard form. Now, the axis of symmetry is whatever the h value is. And by h value, I mean ignore the sign in front of it. All right, so if there's a minus in front of it, that h is positive. If there's a plus in front of it, that h is negative. So in other words, whatever sign is here, flip it when you pull it out of the function. So that's only for h. Whatever the sign is in front of that h in the function, you flip it when you pull it out. So that's why in the previous one, it was a +4, but the vertex itself was a -4. We had to flip that sign. The vertex is HK. So it's H. Again, you would flip that sign when you pull it out. And then K. K, you keep the sign. So K, you keep the sign. H, you flip the sign. All right. Now, for the y-intercept, we would just substitute 0 in for x and solve for y. All right. So standard form is the easiest way to get the y-intercept. Vertex form is the easiest way to get the vertex without doing a whole lot of effort. All right. So let's try this. So if I look at this next example, what is the a value here? So what's the a value? So look at where the a is placed in the formula. What would the a value be? Here. -1. It'll be right here. That's my a. So a is -1. So my pattern for graphing is if I run let's call x units, from the vertex, I would rise negative x squared from vertex. So you're always going to square it, but whatever the a value is, that's what you would apply to it for the pattern. Now, again, if the pattern confuses you, by all means, put it in Desmos, get a table, and then plot points. But your table should include the vertex and at least 2 points on either side of the vertex. Yes. Yeah. So, now, before we even graph anything, what's my vertex? So I can pull my vertex straight from the graph. It's 1, 3. Good. So here's my h value. Here's my k value. Your vertex is always the point HK. So we flip the sign of the H. That becomes a positive 1. And we keep the sign of the K. So my vertex is the point 1, 3. So transformations. All right. So let's kind of discuss this. First off, do you guys think I'm going to have a shift in there, so a translation? Do you think I'm going to go left or right something, up and down something? Yes, because think about it. Our parent function vertex. So the vertex of parent, or x squared, is 0, 0. So how do I get from 0 to 1, which is the new vertex? I do what? How do I get from 0 to 1, guys? Add 1. So to get from 0 to 1, I add 1. How do I get from 0 to 3? I added 3. So here's my question. What did I actually do direction-wise? So if I added 1, so if I'm on my number line, if I added 1 vertically, so on a horizontal number line, if I added 1 horizontally, what direction did I go? Did I go to the left or to the right? You went to the what? The right. So we went right 1. Now, if I added 3 vertically from 0, did I go up 3 or down 3? Up 3. So that's what gave us our vertex. So from 0, I went to the left 1 and then up 3. So that's my vertex. Now, here's the other thing. What direction of opening does my graph open up in? So what direction does my graph open up based off of the a value? Does it open up or down? It opens down. So this is going to open down. Meaning I have a what? A max or a min? We have a max. Now, our parent function x squared, which direction did our parent function open up? Did it open up or down? So if I go back to my parent function, which way did my parent function open, up or down? It opened up. So it was a minimum, right? So what happened transformation-wise to make a minimum a maximum? What did it do? So if I wanted my original function, the x squared, to have a maximum instead of a minimum, what would I have to do transformation-wise? Would I have to dilate it? Would I have to reflect it? Would I have to shift it? What would I have to do? Reflect it. Reflect it over what? The x-axis. There you go. And that's exactly what happens here because we will have a max. So we also reflect over x-axis. So if your a value is ever negative, that's what you do. If If your A value is negative, you reflect over the x-axis. So let's try our trick here. So if I go out 1 unit, so I run 1 unit, that means my rise has to be negative x squared, meaning I square it and then make it negative. So what's 1 squared? So if I make it negative, it becomes, if I make it negative, it becomes -1. So that means I go down 1. Find its reflected partner on the other side. So if I go out 2, what would I go up or down? So what's 2 squared? 2 squared, guys. 4. And since we make it negative, it becomes -4. So we go down 4. So 1, 2, 3, 4. And then get its reflected buddy. If I go out 3, what's my rise? 9. Do I go up or down 9? Down, because it has to become negative. So I go down 1, 2, 3, 4, 5, 6, 7, 8, 9. And then get its reflected buddy. Again, if the pattern does not make sense to you, put it in Desmos, get a table, get some points. All right. So again, the other way you can get this graph is put in Desmos and generate the table. But your table must include the vertex. So if it's not on the pre-generated table, you need to add the vertex into it. All right, so this is what my graph would look like. So what's my y-intercept? We have it on this graph. What's the y-intercept? 0, 2. Now, let's say that we didn't have the graph yet. I could also find the y-intercept by plugging in 0 in for x. So remember, when x is equal to 0, we get the y-intercept. So if I plug it back into the function, negative, I'm replacing the x with 0, so -1 squared or plus 3. What's 0 minus 1? -1. So I have -1 squared times a negative plus 3. What's -1 squared? 1 becomes negative plus 3. What's -1 plus 3? 2. Is that not what we got for our y-intercept? It is. So that's the other way you can get it. But again, you guys have full access to Desmos on your test, so by all means, use it to your advantage. I'm just showing you how you can do it by hand. Doesn't mean you have to. All right? Yes. Yeah. All right, let's try one more of these graphing wise. So first off, we're looking at this equation. What's my A value? -1/2. So that means my pattern is if I run x, I rise -1/2 x squared. So transformations, what do you think is going to happen? Well, first off, let's just get the vertex. What's the vertex that we can pull from the function? What would the vertex be? 2, 5. So we flip the h, so that becomes +2. Keep the k, so that's 5. So if I went from 0, 0 to 2, 5, what did I do transformation wise? Write 2 up 5. Good. Because I added 2 to get from 0 to 2. I added 5 to get to 5, from 0 to 5. Now, since our A value is negative, that means we also did a what transformation-wise? Reflect over the x-axis. So we reflected over the x-axis, again, because of that negative. Now, this time we're actually multiplying by something other than 1. So recall back from Unit 1. Whenever we multiplied a value to our entire function, what transformation was that called? So in other words, we multiplied a scale factor to that function. What was that called? It's a dilation. So we dilate by a scale factor of 1/2. Now we got the axis of symmetry. So what's the axis of symmetry, which we can get from the vertex? X equals what? 2. So I'm going to start by plotting my vertex. So that is 2, 5. So it's up here. Now, since we're reflecting over the x-axis, or A is negative, that means are we going to have a max or a min? So our A is negative. So that means are we going to have a max or a min? We're going to have a max, which means is it going to open up or down? It's going to open down. So that should give us an overall idea of what our picture is going to look like. Now we're going to graph at least 5 points. So we have the vertex. I'm going to use my pattern first, but again, if you want to do that in Desmos, I don't care. So if I go out 1, I now have to do negative 1/2 squared. So what is 1 squared? 1. And then times that by negative 1/2. So in other words, divide by 2, make it negative. What's 1 divided by 2? Okay, you know what? 1's not even. So let's make even numbers. That'll make our lives easier. Because remember, multiplying by 1/2 is the same thing as doing what? Divide by 2. So that means we want even numbers for our runs because that will make our lives easier. So if I go 2 out, what's 2 squared? 4. What's 4 divided by 2? 2. So we're going to go down. So am I going to go up 2 or down 2 because it's negative? Down 2. Now, since my axis of symmetry is right here, that means I can find its partner. All right. So let's do another even number. So let's go, I go out 4. What's 4 squared? 16 times 1/2. Or divide by 2. What's 16 divided by 2? 8. And then I make it negative. So am I going to go up 8 or down 8? Down 8. So 1, 2, 3, 4, 5, 6, 7, 8. And then you find its reflected buddy, and that's over here. So that should be enough. We got a total of 5 points now. So here's my graph. Now, let me show you how you would do that in Desmos. All right. So in Desmos, I'm just going to edit this one. I have negative 1/2. So then x minus 2 and then plus 5. So I'm going to generate a table in Desmos. Hit the gear key, generate table. Now, notice how it's not the prettiest. Okay? We got some fractions in here. I just want whole numbers. Now, I know my vertex is, so I'm going to get rid of all the x's that have fractions as y values. So I'm going to get rid of them. Now, I know that 2, 5 is my vertex. Okay? So I look at the ones that I already had whole values to. Okay? So 0 had a whole y value. What did I do to get from 2 to 0? Do I add 2, subtract 2? What do I do? You subtracted 2. So if I do the same distance on the other side, if I add 2 to 2, what would be its buddy? 4. We get 3. Now, -2, how do I get from 2 to -2? We subtract 4, so if I add 4, 6. And that's how I get -3. So, guys, you can also just plug in random values, like just go down the line and see when you get fractions, but that's just the way you could think about it. So if you get the whole number values, so I had 0 and -2, and I got 3, -3, which, by the way, those are the actual points we actually figured out with the pattern. I would do the same distance on the other side. So if I subtracted 2 from the vertex, that means I got to add 2 to get its vertical buddy. So that'd be 4, and its buddy's 3. If I subtracted 4 here, that means I have to add 4 here. So that would be 6. Oops. If I subtracted 4, that means I got to add 4. So that'd be -3. So again, you don't have to do all that work if you don't want to. You just need to get some happy points and then find its reflective buddy. So these two were my happy points besides my vertex. And what I mean by happy points, whole numbers. All right? No decimals. And then from the happy points, which you can do that on the graph, I find its reflection buddy. Does that make sense to you guys? A little bit. Again, if I'm just confusing the ever crap out of you, just put it in Desmos, generate a table, get some points. All right? As long as you are able to graph that graph, whatever. Okay, so let's look at example 5. Yes. Yes. So we're going to write a parabola whose vertex is given and a point on the graph is given. So remember, we're going to write these in vertex form. So y equals a times x minus h plus k. So you always start with your vertex just to get your h and your k. So if my vertex is 4, 3, what's h and k? So what's my h? Guys, what's the h value of the vertex? It's the x value, because remember, this gives us the vertex hk. So what number in the vertex, or v, is the h value? 4. This is my h, which makes 3 my k. So I'm going to flat out plug these in as I see it in the formula. So I have y equals a times x minus h, because the minus is not h, 4, because the minus is in the formula already, squared. I forgot to square that. Plus 3. Now, we're not done because we still need the a value. All right? So, if I want my a value, I'm going to use this point, I'm going to plug it in for x and y respectively and solve for a. So I have 5 is equal to a times 5 minus 4 squared plus 3. What's 5 minus 4? 1. What's 1 squared? 1. So I have a plus 3, because 1 times a is 1. Or a, sorry. How do I solve for a? Subtract the 3. So my a value is equal to 2. So my full equation is y is equal to 2 times x minus 4 squared plus 3. Now, I wish there was a Desmos way for you guys to do that, but unfortunately, the Desmos way, it would give it to you in standard form, and I would want that in vertex form. All right, so let's try another one, but with example 6. So I'm going to write an equation of the parabola based on the point given, based on the parabola. So there's two things I need from this parabola. I need the vertex, and I need a happy point, meaning it lines up perfectly with two whole numbers. And then I'm going to do the process I just did. So what's my vertex of this graph? What's my vertex? 0, 2. So here's my vertex. That's 0, 2. Now, someone tell me one point besides the vertex that looks like it lines up nicely on the graph with two whole numbers. So a whole number x, a whole number y, meaning no decimals. So if I look at this graph, where would there be a nice point? Owen.
0, -1.
Not 0, -1. 1 negative, -1, 0. So there's one here at -1, 0. You could have also picked this one over here at 2, 0. Either way. So I'm going to use -1, 0. Now, I'm going to start by putting it in the form, the vertex form. I'm going to start with the vertex first. So, what's my h value? Of my vertex, what's the h value? 0. What's the k value? 2. So I have y is equal to a times x minus 0 squared plus 2. Now let's do a little simplifying. What's x minus 0? X minus 0 is just what? Anything minus 0 is always... No. Guys, what's 1 minus 0? What's 1 minus 0? 1. What's 2 minus 0? What's x minus 0? There you go. So I have a to the x squared plus 2. Good Lord. I know it's first thing in the morning on Friday, but good God. All right, now I'm going to take my happy point. I'm going to plug the -1 in for x and the 0 in for y, and then solve for a. So I have 0 is equal to a times -1 squared plus 2. So what is -1 squared? 1. So I have a times 1, so that's just a, plus 2 is equal to 0. How do I solve for a? Minus 2 to both sides. So that'd be -2 is equal to a. So this is what's going to go in my a value for either one of these. Now, if you didn't want to simplify the x minus 0, I wouldn't fault you on that. You can leave it like this if you wanted to. So you could have left it as y is equal to negative 2 times x minus 0 squared plus 2. Or you could have left it as a is equal to negative 2x squared plus 2. I would have accepted either one of these. They're exactly the same thing. Which, doesn't this make sense in terms of the graph? Our a value should be what? Based off the direction of opening of the graph. The a value should be what if it's opening down? Negative. Is the a value negative? Yeah, the a value is negative, so it makes sense in terms of the graph. Okay, one last thing I gotta go through, and then we're done. I promise. Okay. How to convert from factor to standard form. Firstly, what is x minus 1 squared the same thing as? How can I rewrite x minus 1 squared? If you square anything, that's just what? Squaring is the same thing as doing what? Multiplying it by itself. So couldn't I say x minus 1 squared is the same thing as x minus 1 times x minus 1? Yeah. Well, how do I expand that? I would have to do what? So guys, we've already done this before in this unit. If you see something like that, what do? FOIL or box method. So I'm going to do a quick box. So that's x squared, negative x, 1. Pull it out of the box. I have negative 2x. So I have x squared minus 2x plus 1. And then I'm going to bring down the other accoutrements. So I got plus 5 over here times 2 over here. What do you think I'm going to do next to simplify? What do you think I'm going to do next? In your gut, what do you think you're going to do next? Say it again. Well, the parentheses done. I'm trying to simplify to be standard form. So I want it to look like y equals ax squared plus bx plus c. That's standard form. So what do I need to do next? Distribute that to, good, to just the parentheses. So this would be 2x squared minus 4x plus 2. Bring down that plus 5. What's my last thing I got to do? 5 plus 2. I got to combine those like terms. So my standard form would be y equals 2x squared minus 4x plus 7. This is the standard form of this. Those are equivalent functions. If you graph those two functions in Desmos, you get the exact same graph. All right, now I know that was quick, okay? We'll do more practice with this on Monday. Your homework for the weekend, I want you to do pages 27, 28. So in your packet, your homework for the weekend is pages 27 and 28. By the way, guys, I post all the keys. So as you're doing it, if you need to check yourself, maybe check the key page. The keys are already there. So make sure your calculators are put up. Clean up around your desk.